Hi, this is Miss Cross. We're going to talk today about properties of matter, physical and chemical changes, and the states of matter, which are in your packet on pages 19 through 21. The notes are going to be completed through just this instructional video. Pardon me. And you'll complete page 22 for homework practice. We are still testing over this unit tomorrow. I know we were supposed to be testing today, but because of my absence, I've postponed it by one day. Hopefully that's agreeable to all. The entire packet, as a reminder, is going to be due tomorrow. That includes both the review pages 23 through 25, plus all the homework assignments that you've had throughout the unit. Just to start off, we should be understanding, or you should recognize, properties of matter. You would have covered these in 8th grade and probably before. A physical property would be any sort of characteristics of matter that you could observe or measure without actually changing the substance. Examples, of course, color, mass, shape, size, the boiling point, the melting point. That doesn't actually change the physical property. So a lot of students will confuse boiling with cooking, not the same thing. The water boils, the pasta cooks. Density, we just did a whole lab on that. That is a physical property of matter. You measured the mass and then you measured length, width, and height, and you were able to calculate the density. The states of matter, solid, liquid, or gas, the classification of matter, those would all be physical properties. Now, chemical properties can only be observed when they undergo some sort of chemical change. Examples would be reactions with water. For instance, all the group 1 metals react with water violently. If something's flammable, if something's explosive, we also use the terms corrosive. You might remember that from when we first started. So those are all going to be chemical properties of matter. Intensive versus extensive, we've kind of worked through that a little bit, talking about how if you add extra when it changes, we would consider that an extensive property. Intensive properties do not change. So density, remember, was a calculation. So it's a ratio of mass to volume. That doesn't change. And so because of that, it is an intensive property. Also, temperatures such as boiling point or melting point, those are intensive because they do not change no matter the size. So I always think of extensive properties like mass or volume as something that changes when you add extra. So if it changes when you add more, it would be an extensive property. There's a couple of examples here. I like the pictures much better. For instance, hardness, right? That's an intensive property. That's not going to be extensive. No matter how much you have, it's still going to be hard, or it's still going to be soft, right? The color doesn't change just because you have more. Luster, you may not know what that means, but luster would be like how shiny something is. um, Conductivity, right? Something either conducts electricity or it doesn't. Um, Something is magnetic or it's not. So these are all intensive properties, but anything that changes when you add more would be considered extensive, like a volume, a mass, a height, a width, a length, um, etc. Okay, so identifying a physical change versus chemical change. Now, changes are a little bit different than properties. You have to be able to distinguish between a physical property and an actual physical change. And it's all about looking, at the noun versus the verb. So if we're talking about a physical change, a change in the substance that does not change the identity. I always tease about my COVID-19, not actually COVID, but like the extra weight that I gained, right? It's a physical change, but it is not a change in who I am or my identity. So if we're talking about like a state change, a state is the same as phase. So if I go from solid to liquid to gas, those are all state changes and they must be physical because we are not chemically altering the composition or the compound formula. Other examples include like cutting or grinding, shaving, melting, freezing. A tricky one, dissolving, right? I dissolve sugar in my tea, but it's still sweet. Remember, that's a physical process. We talked about that a little bit when we were talking about separation using physical means. Well, physical changes like dissolving is reversible. So, a good way to think of a physical change is something that usually is reversible with a little bit of energy and time. You can reverse that change. Boiling, you could actually collect the water after it boils off and return it back to its original state by cooling it. Now, chemical changes are a little more obvious, I think. Specifically, we're looking for four signs. Now, the main one is going to be color change, most of the time a precipitate when it forms a cloudy substance. I like these pictures here below because they actually are all examples of precipitates. So, a precipitate is an actual solid that's going to form. So, if you see a cloudy substance that forms inside the test tube, or when you mix two chemicals together, that would in fact be a precipitate. So we might have a color change. Sometimes that color change accompanies a precipitate. You might see bubbles, right? A gas being evolved or produced. So it's being made. A temperature change. Anytime you have a heat exchange or any sort of energy exchange, that would in fact be a chemical reaction occurring. So any sort of chemical reaction that takes place would have one of those four signs. Now, what do those four signs all have in common? Well, no matter the type or the sign for chemical reactions, you will always see a new substance. So, a new substance must form anytime there is a chemical change in matter. You have to know these four. You must know these four examples, but even more importantly, you have to know that those four examples all produce a new substance. Chemical reactions, again, when we talked a little bit around the beginning of the year, talked about Dalton and the law of conservation of mass. He was trying to prove or trying to kind of explain that. And so what he discovered and what the scientists through the years have found out is that matter is never actually created nor destroyed. It's actually just being turned into something else or something new. So every atom that's present before will also be present after. And so I like to say, what goes in will come out. It just will look a little bit different. It changes at the end of the process. So during a chemical reaction, the atoms that make up the original substance are just rearranged to make that new substance. Now, we call the substances before the chemical reaction reactants. That makes sense, right? They're reacting to produce a product. And so we've got reactants here on the left. These are in the green, and the products that form after the arrow on the right will be your products and what's being formed or made. And if you were to count up all the nitrogens, notice there's one nitrogen on the left, there'll be one nitrogen on the right. You've got three hydrogens plus one more, that makes four hydrogens. There's four hydrogens here on the right as well. And then, of course, one chlorine and one chlorine on the right. So what goes in will be the same number of atoms on the outside, on the product side. Now, we also talk about phases or states of matter when we talk about chemical and physical processes. So, a change in phase will always be a physical change. Boiling something is not chemical. We're not talking about like a pot of boiling water to boil pasta. Pasta is being cooked. But when we're talking about a phase change, so boiling is physical because it's actually taking the liquid water and vaporizing it into vapor, water vapor, but it's still H2O. So this is a physical process. Now, the state of matter will always be dependent upon the temperature and pressure. So if I heat something up, it will go from a solid to a liquid. If I keep heating it even more, it'll go from a liquid to a gas. Likewise, we could always cool it and just reverse that process. Now, pressure can also change a phase of matter. Think of like gas having all those spaces between it. If I compress it and put it under a lot of pressure, I can actually liquefy it. Think of liquid nitrogen, right? You probably have heard of that. It does some really cool stuff if you look it up on YouTube. And it will freeze things. So, liquid nitrogen, if you put it under pressure and you cool it, you can actually take nitrogen, like in our atmosphere, air that we're breathing, right? And we can turn it from a gas into a liquid. More examples, a little bit hard to see here, but we've got least amount of energy would be in the solid state. The most amount of energy would be in the gas state or even in the plasma state. Now, you're really only needing to know solid, liquid to gas, but plasma is a common state. It's actually the most common in the universe because it includes our sun and our stars. Now, it's really going to be helpful to recognize that melting and freezing actually occur at the same temperature. Vaporization and condensation also happen at the same temperature. So as I move from a liquid to a gas, then it's vaporizing, but as I move from a gas to a liquid, it's condensing or condensation. Now, to move from gas to plasma, we're going to have to ionize that gas. And so, what it does is it actually takes these particles and it kind of, remember, cations and anions, we charge those particles to make light, to make energy. And so neon signs are good examples of this. The lights in the fluorescent light bulbs above your head. If you're watching this in classrooms, then those signs, those lights are actually plasma, just like the sun and the stars. Now, you are going to be expected to recognize solid, liquid, and gas, their simple properties. For the most part, we recognize that solids are going to be rigid. A lot of times we'll say they have a fixed shape. What that means is it doesn't change. Sometimes you'll see that written as definite shape, right? Fixed or definite means it's not changing. A fixed or definite volume, again, not changing. So those atoms are packed together because they're strongly attracted to each other. I highlighted that or bolded that text for a reason. You're going to see it again. Make sure you understand that. Now, solids are in the lowest amount of energy. If I add a little bit more energy, it starts to break up that solid structure and it starts to form a liquid. And so a little extra energy would allow that shape to be more fluid. So we use the term fluid because it allows for motion and movement. And liquids, I think most of us recognize are fluid, but they don't have a fixed shape. They will take on whatever shape of the container that they're in. Now, intermolecular forces we're going to talk about soon, but for the most part, what you need to understand is that the liquid, with that extra energy, it allows it to move more, and we consider that fluid. Now, unlike gases, they are not compressible. So I don't know if you've ever, squeezed a water balloon and it literally explodes right in your face. You cannot compress that. It's going to burst and open, and spill all over the place and make a mess. But liquids are not compressible like gases. And that's because gases have a lot of space between them. So what's important about having all that space is that they're not rigid. They are also fluid, but they also don't have a fixed volume. So you might remember diffusion from biology and probably some earlier science classes like 8th grade. No fixed volume for gases. Liquids, they come in volumes. You buy sodas in liter containers or 2 liters or 3 liters. Water bottles come in half liters, like the ones you buy in the packs at the store. They're sold in a specific volume of liquid. Think of milk, right? Half gallons. Those are specific amounts or specific volumes. So liquids have a fixed volume. Gases do not. And that's because they can expand. But because they can expand, they're also compressible. So compressible means I can squeeze all that extra space out and turn them into a liquid. Remember, pressure also changes the state of matter. Now, plasma, again, you're not going to be responsible for having to know a whole lot about plasma, but it's basically super ionized gas. It's one step above gas, and so it's got ionized particles like positive cations and negative anions, and that all happens with really high temperatures. Remember, we're talking about light, we're talking about electricity, we're talking about the sun and stars, so it's a very high energy state. Now, why are liquids and gases both fluids? Because they are able to move around. They have less attractive forces and they spread out. And because they can spread out, they are able to move. Now, again, changes of state and states of matter, sometimes you'll see this as phases of matter. You are going to have to recognize that going from a solid to a liquid means that we're melting. Going from freezing would be in the opposite direction. So liquid to solid would allow it to freeze. Notice these happen at the same temperature. Notice down here, I like the picture. It actually shows these happening at the same temperature, just in the opposite direction. Boiling and condensation, again, same temperature, opposite direction. So boiling goes from a liquid to a gas. Gas to liquid means that it must condense back to a liquid. Last but not least, really important to recognize sublimation versus deposition. Sublimation is actually like oh crud, I can't remember the term, but it's what happens when you have like solid carbon dioxide, dry ice, pardon me, dry ice. Sorry, I had to think about that one. But sublimation is with dry ice, right? It's perfect, right time of year almost. But sublimation, we'd have that solid dry ice, and then it goes directly to a gas. And they call it dry ice because it bypasses that whole liquid phase. So going from a solid to a gas, we call sublimation. I don't have a great way to remember this when this, oddly enough, is when you are expected to memorize, specifically because you've learned all the other ones in earlier classes. But sublimation, I always think, isn't it sublime to look at dry ice? I think it's so cool. Now, the opposite is true for gas to solid. So this one's kind of like deposition would be kind of like hail, right? It's forming hail. It goes directly from water vapor in the atmosphere down into little tiny, tiny ice cubes. So it's bypassed that liquid phase. Again, notice how we're adding energy as we go from solid to liquid to gas, and we take away energy or we start to cool it as we go from gas to liquid to solid. All of these are going to be physical changes. They are not chemical. It is going to be really important to remember that and recognize that. So phase changes are absolutely um, physical changes, not chemical. Now, as I'm going from a solid to a liquid, liquid to gas, and gas to plasma, they're getting more and more energetic. So I've got increased amounts of energy in kind of the stair-step model. And so the energy levels of the particles are increasing and they're spreading out, and so on and so forth. Now, there is a nice little video here if you wanted to watch it or needed to watch it, and you certainly can do that. I do want to remind you that you do have a homework assignment tonight. It's going to be page 22 in your packet. Hopefully that will finish up your packet. We are testing over Unit 2 tomorrow. Hopefully I'll be back, but testing over Unit 2 tomorrow. And that means that the entire packet, including page 22 and the review assignments, are going to be due tomorrow before we start the test. So they are due at the beginning of class, not the end of class. Please don't be late on those. It is due at the beginning of class. I hope that was helpful, and I hope you got what you needed. Please let me know, and you can reach out to me on Remind. Please make sure that you're keeping on top of all of your assignments, because we know that on Friday they're actually going to close up the grade books for eligibility checks. So if you're missing anything, I'm trying to clean all that stuff up. You should have an idea by Wednesday if you're missing anything. Thank you guys. You have a wonderful